Long before James Webb peered into the early universe, another mission, smaller, slower, but no less ambitious, set out to explore our solar system. Tint Voyager. Launched in 1977, the Voyager spacecraft were built during a rare cosmic alignment, an event that occurs only once every 176 years. This alignment allowed a spacecraft to use gravity assists from all four outer planets, Jupiter, Saturn, Uranus, and Neptune, to slingshot from one to the next with a minimal fuel. This concept of gravity assist was relatively new at the time. It had been tested on earlier Pioneer missions, but never on this scale. The potential was enormous, a grand tour of the outer planets. But there was a catch. NASA had a narrow window to launch before the alignment closed. And worse, there wasn't enough time or political will to fund a full-fledged grand tour mission. Congress was hesitant, budgets were tight, and timelines were aggressive. So the Voyager teams made a bold decision. They built two spacecraft, Voyager 1 and Voyager 2, equipped them with 11 scientific instruments, and designed them with flexibility in mind. These spacecraft weren't just for short trips. They were built for endurance, equipped with redundancies in critical systems, including instruments that could be turned off or on as needed to conserve power. It was an engineering gamble, but it paid off. Voyager 2 was launched first, on August 20, 1977, followed by Voyager 1 on September 5. Despite its later launch, Voyager 1 took a faster trajectory and overtook its sibling, and the rest is history. The spacecraft visited Jupiter and Saturn, sending back breathtaking images and revealing features never seen before. Jupiter's raging Great Red Spot, Saturn's majestic rings, and moons like Io, Europa, and Titan, which would later become prime targets in the search for extraterrestrial life. Voyager 2 continued its journey, becoming the only spacecraft to ever visit Uranus and Neptune. It revealed Uranus's tilted magnetic field and Neptune's deep blue atmosphere, filled with supersonic winds and storm systems. Each planetary encounter was like a space documentary unfolding in real time. And back on Earth, scientists and citizens alike were captivated. But the story didn't end there. After their planetary flybys, both Voyagers continued outward and entered the final phase of their mission, the Voyager Interstellar Mission. In just 2012, Voyager 1 crossed the heliopause, the boundary where the solar wind is no longer strong enough to push against interstellar space. It became the first human-made object to enter interstellar space. Voyager 2 followed in 2018, confirming the data and validating one of the most extraordinary achievements in the history of exploration. And yet they're still talking to us. Despite being nearly 20 billion kilometers away, both Voyagers continue to send back data, using their plutonium-powered RTGZU and ancient yet reliable communication systems. Each byte of data that reaches Earth takes more than 20 hours to arrive, traveling at the speed of light across the vast silence of space. And what's even more poetic, each Voyager carries a golden record, a phonograph disc encoded with sounds and images of Earth, greetings in dozens of languages, and even music from Bach, Beethoven, and Chuck Berry. These records are meant as a message to any intelligent life that might someday find them. It's a time capsule of humanity, floating among the stars. The Voyagers are not just missions. They are old legends, monuments to human curiosity, perseverance, and ingenuity. And while James Webb looks outward into the cosmic past, Voyager looks back at us, slowly fading into the night, yet never forgotten. Infinity Beyond celebrates these twin spacecraft, not only for what they discovered, but for what they represent: the spirit of exploration. The idea that even with limited tools, uncertain funding, and outdated technology, we can achieve the extraordinary. Because sometimes all it takes is a well-timed launch and an unshakable belief in the journey ahead.